Okay, good morning, Professor David J. De Los Reyes. Okay, it's August 5, 2023. The time is 1 EM. Okay, my topic for this morning will be college algebra, and this is a long video format, and this will now be lesson number 23. And the title of the topic is actually addition and subtraction of rational expressions, or in layman's language, fractions. Okay, let's proceed. The topic for this morning will be a long video format discussion, and this is college algebra lesson number 23. The title of the topic is addition and subtraction of fractions, or the other equivalent is actually rational expression. So the problem could be addition or subtraction of just simple real numbers, or simply an algebraic expression. Okay, let's proceed. There are two classifications under the addition and subtraction of fractions. Okay, it is a fraction, so it's either that there is a numerator and there will be a denominator. And the so-called addition and subtraction, it could either be that the denominators are alike, or the denominators are unlike, or just simply dissimilar. It could be that the denominator are the same or like, or it could be that the denominators are different or dissimilar. Okay, let's try to bring out the forms of the so-called like denominators. We are given the fraction a over c plus b over c. The operation is plus, that's by addition, and this should be equal to. If the denominator are the same, the equivalent will just be simply the common denominator, and the resulting numerator is actually the sum of the individual numerators. This is true for even three fractions, as long as the denominator are the same. Okay? For the subtraction, it's just the same. We just change the operation from addition to subtraction. So the ratio O over C minus, that's subtraction, B over C, and this should be equal to the right hand side, the common denominator is C, and the resulting numerator will be the difference, because the operation is subtraction, that is A minus B over the common denominator C. Okay? With the unlike denominators, okay, we will now represent two fractions with the different denominator, that is A over B plus, that is for addition, C over D. Okay? And this should be equal to, if you try to notice it, the denominator are different, that is B and D. Okay? So to simplify this one, okay, we try to multiply this one here. That will be AD. Then we try to multiply this, and that will be BC. Okay? And the resulting denominator will be the product BD. This is BD. This has been coming out from the short videos on YouTube. Okay, there are lots. Okay, we are saturated with this type of what do you call this, simplification. So I will bring it out because this is a discussion of long video format. So we are discussing the concept, right? For the subtraction, it's the same. A over B minus C over D. Whether the operation is plus or minus, the resulting numerator will be still the same. Okay, the product AD minus the product BC Since this is a subtraction, this should be subtraction. All over, the common denominator will be the product, BA. Okay? Actually, some of the problems on YouTube shorts are some are easy ones, you know. Okay, some are easy ones. It's only just a nice thing to see that when they try to illustrate how it was done, that's it, right? But there's no hard thing about it. As long as you know the rule on how to add or subtract fractions, you won't get lost. Okay, let's proceed. Example number 1. Perform the indicated operation. Okay, we are given algebraic expressions. This is the first algebraic expression. This is the second algebraic expression. And they are both fractions or simply rational numbers or rational expressions. Rational expressions in layman's language, they are fractions. So this is the first fraction and this is the second fraction. And we are asked to perform the indicated operation. We are asked to take the sum of these two expressions here. Okay, let's bring out the solution. We'll do it like this. The denominator of the first term, we'll try to simplify this or take the so-called factored form of this separately. 1 minus 3x plus 2x squared. Okay, I will try to rearrange. This should be 2x squared minus 3x plus 1. I just put the x squared on the first part because it got the highest exponent, right? So if we try to simplify this one, okay, this now involves factoring. We just passed by the lesson on factoring, right? Okay. The possible factors of 2x squared will be the product 2x and x. And the possible factors of 1 will be a 1 and 1. Okay. But the sign of this plus 1 here is plus. So it could either be both plus. They could be both plus, right? Or both minus. But if we try to check the sign of the middle term, the sign of the middle term is minus. So I think the sign of this one will be negative and this will be negative. Let's try to check the middle term. The middle term is negative 1 times x, which is negative x. And the other part is 2x times negative 1 will be negative 2x. Minus x minus 2x will be negative 3x. Similar terms, right? So if this is minus 1 and this is minus 1, what comes out for the middle term will be negative 3x. So the two binomial factors of this will be the quantity 2x minus 1 times the quantity x minus 1. Okay? So rewriting the given two expressions, okay? Then I will try to put this so-called, what you call this, binomial factors of the first denominator, that is, I will write 4x, and the binomial factors of this are actually 2x minus 1 times the quantity x minus 1, it comes from this, plus 3 over x minus 1, right? And try to observe the denominator of the first one and the denominator of the second one. They are different. Why they are different? Because this is a quadratic equation and this is a linear equation, right? So for us to add it, okay, the denominator should be the same. So for the denominator to be the same, we will maintain the first one as it is, and for the second one, we'll try to multiply this by 2x minus 1 times 3 all over 2x minus 1 times x minus 1. Because this ratio here is actually 1. But we could do it, right? So upon the insertion of 2x minus 1 over 2x minus 1, if you try to observe the denominator now, this is the product of 2x minus 1 times x minus 1. And the second denominator is now 2x minus 1 times x minus 1. So after the insertion of this, we are now adding two fractions with the same denominator. Okay? So the overall denominator now will just be simply this product here. Okay? It's common to both. So it will now pull under this one here. Right? And the resulting numerator, just add the numerators. This is 4x. Okay, this is multiplication, right? So 3 times 2x will be 6x, minus 1 times 3 will be negative 3. And combining similar terms, 4x plus 6x will be 10x, the pure constant will be minus 3, and the common denominator is the quantity. The similar denominator after the insertion of 2x minus 1, that is 2x minus 1 times quantity x minus 1, that will be our final answer. Okay? So the key to the solution is that try to factor out this quadratic equation here into its binomial equivalent, binomial factors, okay? Then try to multiply the second term by the quantity 2x minus 1 over 2x minus 1 so that the resulting denominator will be the same for the first one and the second one. And by using this first concept here, it will be a plus b over the common denominator c. So this is our final answer. Okay? That is just addition of two algebraic expressions. Okay? Okay, let's try to bring out the so-called addition of just simply plain real numbers. Okay, give an example number 2. Add the quantity 3/4 plus 4/5, and what will be equal to? Okay, this is now not an algebraic expression. They are both real numbers. They are both fractions because our topic for the meantime is fraction, right? Okay, let's try to bring out the solution. Actually, we don't even need this LCD here. We could solve this without using the LCD. 3/4 plus 4/5, and this should be equal to the product 3/4 plus 4/5. Okay. I erased that one. If we try to simplify this one, actually you can try to multiply this by 20 over 20. Okay. And what will come out will be this one will be 3 times 5. Because if we try to multiply 3/4, okay, by 20 over 20, what will come out? This is 5, right? So 3 times 5 will be 15. 15. All over its denominator 20 for the first one. The second one, you take 4/5, multiply by 20 over 20. This one cancels, so 4 times 4 is actually 16. Its denominator is 20. Okay, so it seems we are adding two fractions with the same denominator now, so we just simplify the numerator all over the common denominator 20. This is all over 20. So that will be 15 plus 16, that is 31 over 20. So our answer here is 31 over 20. Okay. Where did we get 20? 20 is the product of 4 times 5. Okay. The last example for this morning, perform the indicated operation. We are given still pure real numbers. They are all fractions, and we are asked to add or subtract. So it seems we are on the operation addition and subtraction of fractions. The first operation is plus. The first operation is plus, and the next operation is minus. So we are asked to perform 1/3 plus 1/2 minus 1/4, and what will be equal to? Okay, the simplest solution of this is that try to simplify first this one. Okay. You could simplify it by including the three fractions at the same time, but it is much, what you call this, complicated. So if we try to simplify first 1/3 plus 1/2, so I will let 1/3 plus 1/2, okay? This now falls under unlike terms, alright? So the resulting simplification of this, it seems we are on the short videos discussions of other bloggers on YouTube, right? The resulting, what I call this, simplification of this will be 1 times 2, take the product of this, then take the product of this, and the resulting denominator will be the product of 3 times 2, so this is 3 times 2. So what comes out is 5/6. Meaning to say the addition of 1/3 plus 1/2 is 5/6. So we now know that the value of this is 5/6. We compress it already as a one fraction, right? So this will become 5/6 minus 1/4. Again, the operation is subtraction, and if we try to inspect the denominator, they are different. So if we try to simplify this one, we use this one. It should be the product AD minus BC all over the common denominator BD. So 5 times 4, okay, minus 6 times 1. We go like this, then like this. Then we multiply this one as the common denominator, so that will be 6 times 4. So this will be 20 minus 6 over 24. That will be 14 over 24, both divisible by 2. So this will be 7 over 12. That's our final answer. Okay. I think that's the simplest solution. If you want to add and subtract at the same time, you could do it. The least common denominator will be the product of 3 times 2 times 4. What's that? 3 times 2 is 6 times 4, that will be 24. So you will do like this, 1/3 plus 1/2 minus 1/4. Then you try to multiply this by 24 over 24. Right? So 1/3 times 24, that will be 8, right? That will be 8. This will be plus 12, right? 24 over 2 will be 12. And 24 over 4, that will be minus 6. All over the common denominator 24. So what will come out? 8 plus 12 will be 20 minus 6, that will be 14 over 24. Again, divisible by 2, so that will be 7 over 12. So the final answer will be 7 over 12, same as this one. Okay, if you want to do it at the same time, right? Just find the least common denominator. The least common denominator will be the product of 3 times 2 times 4, which is 24. Then try to distribute it. This will be 8 plus 12 minus 6, all over the common denominator 24. What comes out will be 7 over 12. Okay, that's it, guys. That's the concepts on how to add or subtract fractions. Okay, two conditions: if the denominators are the same, or if the denominators are unlike or dissimilar. Okay, so for those of you who are taking up college algebra, this is for you guys. If you want to subscribe to my channel is at Prof. David J. De Los Reyes at youtube.com. Okay, if you want to share it, please click share. Okay, good morning from Los Angeles, Professor David J. De Los Reyes.